Assalamualaikum and a very good morning to my panel, Encik Alias bin Khamis and Dr. Intan Azmira binti Wan Abdul Razak. My name is Norizati binti Muhammad Nawi, a final year student supervised under Dr. Azia binti Khamis. So here I am today to presenting my final year project 2 regarding to the performance of double chamber microbial cell using soil. So anything regarding to this presentation, you can just contact me at the email address and phone number given in the slide. I proceed to the presentation. The introduction is microbiofusel is the process of microorganism convert a chemical energy to electrical through an oxidation and reduction process which is occur at the anode side and is oxidation process and the cathode side is reduction process. History of this MFC is created by MC Porter in year of 1911. So I proceed to the problem statement. The first problem statement is based on the research study that I made. A lot of researchers used to use wastewater and food waste for this MFC system. So here I am to continue digging the experiment on soil using soil for the MFC because soil have the microorganism that could generate power by releasing the electron. Also, from the previous study, they mostly use the metal-based electrode, which is we know that metal have quite conductive compared to carbon-based electrode, but we know that metal-based is high in cost. And the last one is the value of external resistance used affect the movement of electron by microorganism. So from this problem statement, I create three objectives, which is to identify the production of power density on a microbial fuel cell using different type of soil such as paddy field and grass soil. And the second one is to analyze the performance of double chamber MFC using different type of electrode such as copper and graphite. And the last one is to identify the effect of external resistance on double chamber MFC using 1 ohm and 100 ohm resistance. So scope of this study is to focus on double chamber microbial cell, microorganism in soil which is paddy and grass soil. The material used for the experiment is from 3-dimensional electrode of metal and carbon base which is copper and graphite. External resistance used is 1 ohm and 100 ohm. So literature review for this experiment is which is in choosing anode material, cathode material and effect of external resistance. As we know that for anode material, the oxidation process occur at the anode compartment. So the anode material should be high in conductivity and also high mechanical strength, high porosity, and the most importantly, they are comparatively low cost. We know that metal base has the high in conductivity compared to carbon-based material, but we cannot simply choose a metallic material because we should consider another factor. And the cathode material. In choosing the cathode material, we should consider that the material that high in redox because of the reduction process occur at the cathode side. And we know that platinum has the most high redox characteristic, but is high in cost. Based on the study before, the combination of graphite at the anode and platinum at the cathode side could produce a power density of 150 milliwatt per square, which is it increased 3 times higher than combination of graphite and graphite. For the effect of external resistance, we know the oxidation process occurred by microorganisms has been noticed to be less at high resistance than at lower resistance, where microorganisms transfer the electron to the cathode side through external circuit that connect to resistor. So at smaller resistor value, the electron travel more quickly through the circuit than at high resistance value. So proceed to the methodology. Here is the flow of the process involved, which is the experiment start by identifying the problem and objective. Really do a literature review, research hardware of the system, development of hardware MFC, running the experiment for 3 type of experiment, collect the data for 21 days, do the data analysis and writing the report and ending the experiment. We can see at the left side is the general flow chart process involved for 3 experiments, and at the right side is the MFC setup, which is soil. At the anode compartment is loaded with soil, and the cathode compartment is contained with RO water and connected to resistor. This anode compartment is sealed neatly to prevent the oxygen, while at the cathode side is supplied with oxygen through a small hole at the top of a compartment. Is the general apparatus involved in this experiment, and here is the step for the experiment. Generally, the step for experiment 1, 2 and 3 are the same, but the only difference for experiment 1, it contains of 2 parts, which is part A and part B. Part A is focusing to the performance of soil, which is paddy and grass soil. Part B is to focus on the performance of different electrode. And the anode compartment is loaded with 500 grams of both soil, and it is neatly closed to prevent from oxygen, and the cathode side is contained with 750 milliliter of RO water, and it had been supplied with oxygen through a small opening at the top of the container. And the compartment is connected to PEM, which is salt bridge, and then the circuit will finish by connected the resistor value of 100 ohm. The experiment 2 is the same, but the difference only at the external resistance used, which is 1 ohm. For experiment 3 also same, but the only difference is for the anode electrode we use graphite, and the cathode electrode we use the copper. Here is the equation involved in this experiment. To calculate the area of electrode, we use the equation of cylinder, and to calculate the current, we use the equation of voltage, which is V equal to IR, and the current density also power density. Here are the results for the experiment. Experiment 1 part A is to see the performance of different soil, which is paddy and grass soil. Here you can see that the performance of grass soil is better than paddy soil, which is the maximum voltage that could achieve by the grass soil is 0.12 millivolt on the day 9, and the maximum for paddy soil it's only 0.06 millivolt on the day 8. Here is the graph for power density over current density. We could see here is the maximum power density that could achieve by paddy soil is 0.00055 microwatt per meter square, and the grass soil is 0.00218 microwatt per meter square. You can see here that the difference between value of paddy and grass soil is huge, different happen in here. And for the next experiment is to part B. The maximum power density that could achieve by paddy soil is 0.155 microwatt per meter square, and the grass soil is 0.785 microwatt meter square. And also here there is a huge different value happen between paddy and grass soil. Here is the result for experiment 2, which is graphite electrode. The maximum power density that could achieve by paddy soil is 0.015 watt per meter square, and the grass is 0.0216 watt per meter square. You can see here is for the experiment 2, the difference that happened between paddy and grass soil only in a small value. Next is for the copper electrode. The maximum power density that could achieve by the paddy is 0.0222 watt per meter square, and the grass is 0.028 watt per meter square. And also here the difference is all in a small value. And the last one is experiment 3. Maximum power density that could achieve by paddy soil is 0.0093 watt per meter square, and the grass is 0.0178 watt per meter square. So here is the comparative result for the average current density and power density for experiment 1, 2, and 3. For the experiment 1, part A is to see the performance of microbiofuel cell using different type of soil, which is paddy soil and grass soil. You can see using graphite. You can see here grass soil has the better performance, which is for graphite 0.0073 milliampere per meter square for current density, and 0.00054 microwatt per meter square for power density. For part B is to see the difference performance for different electrode, which is graphite and copper. We can see it both soil copper have the better performance, which is for grass soil is the most better one with the current density of 0.065341 milliampere per meter square, and the power density is 0.33324 microwatt per meter square. For experiment 2 is to see the performance of microbiofuel cell using different resistance value, which is 101. You can see here is there's a huge different value that could achieve by 1 ohm resistor compared to 100 ohm resistor. So based on 1 ohm resistor, the grass soil for copper electrode is the highest one with the value. Current density is 59.5457 milliampere per meter square, and the power density is 5.6396 milliwatt per meter square. And the experiment 3 is to see the performance of combination different electrode, which is we use graphite and graphite, combination of graphite and graphite, and then the combination of graphite and copper. So based on this experiment, grass soil also show the higher value, but for this experiment, the combination graphite and graphite has the better performance with the value current density is 56.041 milliampere per meter square, and the power density is 4.062. So the conclusion for the experiment, based on the objective, 3 objectives that I listed before, the collected data showing positive result for experiment on grass soil, which for objective 1, which to is to see the performance of MFC using different type of soil, and this conclude that the grass soil show the better performance compared to paddy soil. And for the objective number 2 is to differentiate the performance of electrode material, which is based on the result, we could see that copper gave a better performance, while for graphite, the performance is behind copper since it has a lower conductivity. And the last objective is to observe on the external resistance, which is based on the experiment 2, we could see that at smaller resistance, the electron travel more quickly through the circuit than at high resistance, because the value of current and power density that we could achieve at during experiment 2 is for 1 ohm is higher compared to 100 ohm. And here is the reference that I refer to, and then this is the appendix MFC setup, and here is the short video for the experiment for paddy soil. This one is the close out for cathode compartment and anode compartment, which is cathode contained with water and anode contained with grass with soil. And that's all for me. Thank you.